Welcome back. Super excited moving forward. I'm going to talk about the types of machine learning that are out there and what is the best one to use when you're encountering a machine learning solution. So here are the basic three types of machine learning that we can implement. We can either do a supervised, unsupervised, or reinforcement learning. Each of them has its own advantages and some disadvantages, but primarily we are looking to do a supervised machine learning with our data. So I'm going to talk about what supervised is, what the differences are among all of these three different types of machine learning. So for instance, the supervised would be a task driven, such as you can implement an algorithm such as regression or classification that we talked about earlier. And unsupervised is data driven because in unsupervised you don't have a labeled data. In other words, you don't have a structured data in column or row format. Well, you may have it in Excel format, but it's not really, it's just raw data, right? And then reinforcement is where we use an agent where it learns as it moves through a maze, for instance, or each step it's learning, right? So here in reinforcement, the algorithm learns to react to the next step or the environment. First is the supervised learning. So here is simply where what we do is we teach or train the machine learning using our data that we have already collected, which is well labeled. That means some data is already tagged with the correct answer. Here the machine itself or the algorithm is provided with a new set of data each time, right? So you're basically inputting data into the supervised learning algorithm analysis, and that training data which produces the correct outcome from that labeled data. Now remember, we talked about labeling, we talked about features. Well, we are going to talk about features in depth, but we did talk about what a label is, right? What a variable is briefly in the previous lessons. So here the data is simply fed in. Labeled data is in fact fed in to the algorithm, and then it's going to create the output or the prediction, right? The human experts, we simply act as a monitor, right? So we are the monitoring agency where we feed the particular computer with training data that contains the input, and we show it the correct answers, and from the data the computer should be able to learn the patterns, right? And that's important because that's really what machine learning is all about, learning from our data that is being input each time, because it's taking that labeled information and then spinning out the desired output, right, or the prediction. So that's really supervised learning, which is the key in machine learning. So what you would want to do is ensure that your data is labeled and it's actually supervised learning, going through this process. But there are instances where you don't have labeled information, okay? And by the way, the real challenge in machine learning is getting labeled information, because typically data is not labeled, it's just data, right? It's sitting there on the servers or within a repository, and all you have to do is just collect the data. But then you have to start labeling it, right? Which can be a cumbersome task. Keep that in mind. So what do we do when we don't have the labeled information? But before we talk about what we actually do, let me run through a simple supervised learning example. So let's say you get a bunch of photos, right, pictures, with information about what is on them. And then you train a model to recognize new photos. Let's say you have a photo of a bird or types of bird, right? So you're training the model to recognize these new photos. Then you have a bunch of molecules and information about which are drugs, and you train a model to answer whether a new molecule is also a drug. So two different examples that I'm talking about here. If you use classification methodology or algorithm, the machine is trained to classify something into some class, okay? So either it's going to say whether a patient has a disease or the patient does not have a disease, whether an email is spam or the email is not spam, right? So a simple classifier, yes or no, or true or false. You can also implement the regression, where a machine is trained to predict some value like price, weight, or height, such as predicting houses, predicting property prices, predicting stock market price. There you go. I'll just give you a tip, right? So you can take the historical data and then actually create a machine learning algorithm to create or predict your stock market prices. So just an example of supervised. Next, let's take a look at unsupervised learning. The unsupervised learning is where you basically don't have a labeled data, right? So the information is just primarily raw, you just collect the data. But here in unsupervised learning is where training a machine using information that is neither classified nor labeled and allowing the algorithm to simply act on the information without any guidance. So you're not really giving it a structured or labeled information. You're just throwing in data, and now the machine is going to kind of take a look at all this information and then predict, right? So the task of the machine is to simply group unsorted information according to similarities, patterns, and differences without any prior training of data. So now it's just going to look at this information and try to figure it out, right? Make groups of similar data, find the patterns of the data or differences between data itself. So it is the family of machine learning algorithms which are mainly used in pattern detection and descriptive modeling. So let's take a look at an example of unsupervised learning. So let's say you have a bunch of photos, right? Similar example of 6 people, but without information about who is on which one. And you want to divide this data set into 6 piles, each with the photos of one individual. So you don't have knowledge of who is on which picture. In another example, let's say you have molecules, part of them are drugs and part of them are not, but you do not know which are which. So you want the algorithm to discover the drugs. Okay. Now, since the data is not labeled, the algorithm that you're going to use for machine learning is clustering. One of the algorithms that you can use, right? So the clustering problem is where you would want to discover the inherent groupings in the data, such as grouping customers by purchasing behavior, by the type itself, maybe by the color. Okay. So each of these patterns are going to be identified and it's going to be put into a cluster, right? A group. So on a chart, for example, you'll see just a bunch of dots or groups, right? So this is data being separated from other data and grouped into similar data types. The last type is the reinforcement learning. And this is simply, think of this as, you're giving a reward to the next step, right? So if you have an agent identified, let's say, and goes to the next step and doesn't find it, it goes back and then finds another route, right? So this is on a macro level, just think of this as reinforcement learning. So it is employed by software machines to find the best possible behavior or path it should take in a specific situation in order to maximize its performance. So how we accomplish this is by a reward feedback mechanism, right? It's required for the agent to learn its behavior. And this is known as the reinforcement signal. So to produce intelligent programs or reinforcement learning, we need to go through about 4 steps, right? So first, the input state is observed by the agent. Decision is made by the agent to perform the action or not. Then the agent receives the reward or reinforcement from that particular next step or environment. And then the state action pair information about the reward is stored. So it's an iterative process where it's repeating itself at each different step and trying to find a way. Let's take a look at a visual example. So here in this particular picture, you see the agent, right? Which is this robot here, and you see a bunch of fires and, of course, the diamond bottom right corner. So if the agent has to travel to the diamond itself, it would not know where to go, right? So it'll just go vertically up 2 boxes, and then right, it's going to see a fire. So it's going to come back down and then find its way, right? So that's how it's going to navigate by reinforcing and reiterating all of the next steps. And eventually it's going to find the diamond. So the next time, right, after it learns this pattern, it's just going to go straight to the diamond. That's reinforcement learning. So I hope you're now comfortable with the 3 types of machine learning type: supervised, unsupervised, and reinforcement. If you have any questions, feel free to post in the discussion area. I'll be glad to help with this. Let's move to the next lesson.